In this video, I want to very quickly cover a few concepts related to rate of return. For many of you, this should be just a refresher, but I find that sometimes somebody will have a gap someplace or not have connected a dot entirely, and so to be able to move on with the rest of the discussion, I think it's useful to go ahead and cover off on this. So first, what do we mean by a rate of return? Well, first of all, you probably hear this all the time in finance, the return on this, the return on that. We mean rate of return, and so it's usually a percentage. They're usually stated on an annual basis. And so when we talk about the rate of return, if we ask for what the return on something is, we're usually saying what is the percent return per year on that thing. And when we think of the return, it's simply the amount that is returned, so money that you get back in a year divided by whatever the initial investment was. And so you can divide those and basically get to a percentage. Simple example of this, assume that you invest $100 or $1,000, and each year this thing returns $100 every year forever. So it's what we would call a perpetuity. The rate of return per year is then 100 over 1,000, so that equals 10%. So you have a 10% return, and that's what you would usually say. You might just say it has a 10% return, and you just need to know that by that what we mean is a 10% return per year on whatever it was that was invested. That's a very simple example. Obviously, you can construct examples that don't have the same amount every year. And so you can do that one of two ways. You can either explicitly solve for an implied rate of return, and that's a little bit more complicated process. We can show that at a later time. Or you may just kind of average the returns per year if they just vary a little bit. But anyway, either way, you usually talk about then sort of an average return rather than a exact number if that's happening. And so you also could have, rather than just something that is a constant return over a period of time, it may be that it's a return that grows every year by some amount, or a dollar amount that grows every year. A good example of that we run into a lot in finance is that you may get an amount that grows with inflation each year. And so inflation is typically between 2 and 3%. You would assume whatever that inflation rate is. And so you want to solve for it. And of course, we would just use the value of a growing perpetuity approach to this, saying that the $1,000 you invested is equal to $200 each year divided by whatever the rate of return is minus 2%. You would solve that out. You can do. I leave that for you to do. It's a simple algebraic solution. Comes back and basically says, oh, so R, which I'm using as our rate of return, is 22%. So doesn't take a lot of rocket scientists Scientology, I guess is what some people say, but don't have to be a rocket scientist to figure that out. Now, up to this point, we've just talked about return as something general. I want to cover off three quick terminology things here. There are really three different kinds of return that we often refer to in finance. One is the required return. So that is usually a return from the perspective of an investor, and it is the minimum return that they would hope to make on a project in order to make it worth their while to invest in it. And so if they believed that for any reason that it was going to likely return less than that, then they probably wouldn't invest in it. There is the expected return on a project. That is the average return that the investor hopes to make. Or maybe you're a project developer and it's the average return on the money invested that you expect that you're going to get from the project. Again, over its life, it can have different returns, but you're sort of backing into what that would be on average. And then there is the realized return. The realized return is the amount that you actually make on the project. So the first two One is a wish, one is a forward-looking estimate, and this last one is backward-looking, what actually happened. Give you a quick kind of example on that. Let's imagine a project, and let's just say that we have the project that there's really only 3 scenarios for it. Scenario 1 has a 25% chance of happening. In that case, you're going to lose 10% of the value of your money. So whatever you invest, your return is going to be that you're going to have to pay in an extra 10%. Second possible outcome is that you get a 20% return each year. And so there's 50% likelihood of that. And so whatever you pay in, you'll get 20% back each year on average. And then the last scenario, the best case, is that you might get a 40% return. So each of those returns, those are forward-looking scenarios, but what we're saying is one of those will be the actual, okay? And so if you just did a probability-weighted calculation on those, so 25% times minus 10% plus 50% times the 20% likely case plus 25% times the 40% best case, and you added all those up, you would get an expected return of 17.5%. And so that would be the expected return on the project, is 17.5% a year. Now, the investor then will say they have a required return, and it could be less than the 17.5%, in which case you would do the project. Could be more than the 17.5%, in which case the investor wouldn't want to invest in this project, and so you wouldn't get money from them. You might get it from a different investor, but you wouldn't get it from them. Now, that's starting out. To put the actual return in perspective, fast forward to the conclusion of the project and what actually happened. Remember, we said only 3 possible outcomes. So either you got, as an actual return, minus 10%, you got 20%, or you got a 40% return. One of those is the actual. So when we talk about this required return that our investor wants, you have to wonder what goes into that. How does an investor come up with a required return? In a prior example, we might have said the investor required 15%. Why 15%? Well, here's the deal, and it just is what it is. For any particular investor, for any particular project, you'll never generally know exactly why they come up with their required return. In fact, in many cases, they may not even know what their required return is. They may just be able to react to the project and say, I like it or I don't like it. And sort of implicit in that is, if I like it, it's because I think that it will return more than what I require for a project like that. And if I don't like it, then it's probably because I don't think that it gives the level of return I want for a project like that. So we don't really know for certain. What we generally see and what we find kind of makes sense with what we see in the market in terms of returns is that the investors generally want a few things. They want some minimum rate just to give up the use of their money. And so that's what we would call time value of money. If I had the money now, I could do things with it. I don't have it now. That's an inconvenience because I've now lent it to you or invested it in your project. And so I need a little something to compensate me for that. That's called the real rate of interest. And then on top of that, it's possible that over the period of time that you have my money, and before I get any of it back, I lose purchasing power. So things become more expensive, and so I need to get compensated for that. Well, the loss of purchasing power we call the inflation rate, and so that goes into the required return as well. Last one's sort of the biggie, compensation for risk that the actual return will be less than the expected return. So in our project, there was a 25% chance that we would wind up with a number less than 17.5%. In fact, it was a negative 10%. And so an investor might look at that and basically say, I need something extra for that risk. Granted, it may not happen all the time and maybe doesn't even happen most of the time, but I need a little something extra to make up for that. And I can't tell you what they do on that. Every investor is different. Some of them are very wary of risk and they would need a lot of return for that. Others maybe not so much. But conceptually, we think in terms of that there is a risk premium element to the required return that somehow relates to the level of risk that they've taken. This last thing, I throw it in here for completeness. Some investments, you get tax breaks on them. So the returns that you get, some portion of the return, maybe all of it, of the return, isn't taxable. And so when that happens, you may also need to adjust your return, your required return, for the fact that on an after-tax basis, you would expect that two projects that are similar have the same after-tax return. And so you might just do that adjustment. Now, mathematically, it might look like this. It might be the real rate plus the inflation rate plus a risk premium times some tax adjustment. Quite frankly, from a theoretical standpoint, there's a lot of questions about exactly how all that goes together. Is it an addition? Is it a multiplication? Is there a cross product? Nobody really knows for sure. But for our purposes, we're just going to use sort of this simplified approach just so that conceptually you can kind of wrap your head around how it works. So in our example, we could imagine the investor wanting a 15% required rate of return. Maybe they need 3% for the real rate, 2% inflation rate. They decided they wanted a 10% risk premium. We didn't talk about any tax benefits on the project, so there's no tax adjustment. So their required return would be the 3% plus the 2% plus the 10%, be 15%. Again, I'm not saying that mathematically that's what every investor does in their head, but that's sort of conceptually how you want to think about it. So we now know that there are projects that have returns. The expected return on the project is higher than what the investor's required return is. So let's just use an example of that. Assume we have a project developer. They're looking for $1 million investment on a project. It expects to return $200,000 per year, growing at 2% a year for inflation. So in the first year, $200,000, next year, $204,000, I guess, whatever that is. They're talking to an investor. They're interested in the project. That investor requires a 12% return for a project of this nature. So that's their required return. So we got to figure out what the expected return for the project is. We got to figure out what the investor, we know what the investor's required return is. And then we know that the project developer, their job is to secure the $100 million that they need for the project at the lowest cost of capital possible. Okay, so we know right off of the bat that what the project developer probably, well, I'm jumping ahead. Question is, how does the project developer handle this? Here's the deal. If the project developer sells 100% stake in the project to the investor for $1 million, then the project developer is basically saying, I will give you in return for $1 million, $2.2 million, so not 2.2, $0.2 million, and you're going to discount that at whatever the required return is minus 2%. This is just our perpetuity formula. And again, you can solve this for yourself, but that works out to a 22% return. Now, put that in a perspective. If that is what the return to an investor for $1 million investment is, then that means that the developer has a 22% cost of capital. Okay? So, in a world where the investor only needs 12%, the project yields 22%. If the project developer gives 100% of the project in return for that, then they are basically overpaying for the money. So the job of the project developer or inside of a company, the job of the finance department raising money is to not overpay for the money that they need to invest in the company. All right, so quickly we can figure out how much are they overpaying. Well, let's see. The investor only requires a 12% required return. And so if we were to take the 0.2 million divide it by the required return of 12% minus 2%, we come up with a value of $2 million. Simply put, that means that the investor looks at this project and says, that project's worth $2 million. Okay? Now, if I am the developer, I could just say, well, if you want a 100% stake in the project, don't give me $1 million, give me $2 million. And that would be getting fair value for the project. Now, of course, the question is, what are you going to do with the other $1 million? And the answer is the project developer is going to put it in their pocket. That's their compensation for finding and putting the project together. The investor shouldn't care because they're going to get their 12% return. So that's one option that would allow the project developer to somehow make sense of this difference between the required return the investor wants versus the expected return on the project. Just take what the project is worth, not what you need for investment. The second possibility is that the project developer could decide to only sell a smaller stake in the company. So if the company is, or the business opportunity, the project, if the project, 100% stake in the project is worth $2 million and they only need $1 million, then they could sell a 50% stake in the business. So the way that would work is that the investor, instead of getting 0.2 million each time, would get 0.1 million each time. They'd get half of it, and the rest of it would stay with the project developer. And again, that would compensate the project developer for having put the deal together. Here's the key. It is the project developer's job to negotiate the best deal. Okay? If they are good negotiators, then they will bring the cost of capital for the project in line with the required return from the investor. And so the cost of capital will be 12%, the required return will be 12%. And we can just make that assumption for both. However, key thing here that I want to emphasize, a lot of finance and financial theory basically says treat those as the same. They're not the same if the person raising the money, so the project developer or you as a financial person inside of a company, if you don't do this negotiation, if you don't negotiate your cost of capital down to that, the investor is not going to say, oh, I should only give you this much money, I should only take this much stake, or I should give you more money, or whatever it is, to make this fair to me. Remember, for them, the required return is the minimum that they will take. If you just offer it up to them, they'll take more, and then your cost of capital will be more. And so a lot of the theory around finance and cost of capital and required rates of return that we'll be talking about later on, all that theory assumes that there will be a negotiation between the investor and the person that needs the investment money, and that where that negotiation will finish is it will be the minimum amount that the investor has to pay in order to get the money, right? And the maximum amount the project has to pay to get the money, and the maximum amount the investor is willing to pay in order to get the project. And so these two will be equal. If we don't have the negotiation, that does not happen. Anyway, I know this is sort of basic and fundamental, but I just want to make sure we connected the dots for everybody. Thanks.